Hello guys, this is Akshay Daga. Welcome back to APDaga's Dumb Box. And in this video, we will talk about inheritance in Python programming language, and it is a part of OOPS, like object-oriented programming language. It has multiple features, and inheritance is one of the basic feature of that. So in this video, I will talk about what is inheritance and different type of inheritance. So in this video, we will cover the first type, that is simple inheritance. So let's start with what is inheritance. So in real life, from English word inheritance, you get some idea. So basically, if we talk about a particular person, let's say about me or any other person, all of us inherit some of the skill set, some of the qualities from our parents, right? So that is inheritance. That's what we say, like a particular person, maybe his physical appearance, maybe his skill set, maybe soft skills, talking style. We sometimes we say that, okay, you got it from your father, you got it from your mother, right? So that is an inheritance. So to make it simple, we get some of the features from our parent. Okay, that is inheritance. So in programming language, what it is? So in our earlier video, we have talked about classes and objects. Okay, so if we are talking about class, so let's say there is one class which is parent class. So we can create another class. We will call it as a child class, so that it will inherit all the features, all the parameters from the parent class. Okay, and on top of that, child class can have some extra features, but whatever features were available in parent class, all those features, all those parameters, all those methods will be inherited as it is, so that we don't need to write it once again. We don't need to do the repetition work. Okay, so that is what inheritance is. Now the part is why inheritance is required, why this feature was needed. So I'll give you one example. Let's say earlier we have written a code for a simple calculator. Okay, so simple calculator means all plus, minus, division, multiplication, and basic operations. For that, we have written a code, we have written a class, and name of that class was simple calculator. Then after some days, someone thought of writing a code for scientific calculator. So scientific calculator means obviously it should have all the basic features. Okay, on top of that, we need to add some extra features, maybe sine, cos, and something like that. So why we should write all the programming, all the line of codes once again, which we have already written for simple calculator? So in that case, what we will do, there was earlier one class, the name of the class was simple calculator. So we will inherit all its properties as it is into a child class. The name of the child class will be a scientific calculator, so that while writing a code for scientific calculator, we will make use of whatever code we have written earlier for simple calculator. So in that way, we can use inheritance. So I'll share my screen to make it more understandable for you. So let's say there was a parent class. Parent class is also known as a base class. Okay, so I'll write parent here, the parent class. So it was nothing but a simple calculator. Okay, then we derived some of the features or all of the features from parent class to create a child class. Okay, so child class. Okay, and child class is created for, let's say, scientific calculator. Okay, so this kind of inheritance, basically one parent, one child, this kind of inheritance is known as single inheritance. Apart from single inheritance, there are other type of inheritance. The name for that are multiple inheritance, then multi-level inheritance, then hierarchical inheritance. So there are total 4 types. So in this video, we'll talk about the first one, that is single inheritance. So diagram for that will be something like this: one parent and one child. One child is inheriting properties from one parent. That is simple inheritance. So I'll clear this and I'll show you how we can write the code for the same. So I'll do one thing. I'll create one class, that is class, I'll give it the name as a parent. You can in some of the websites you will see as a base and derived. So parent means base, derived means child. Okay, so I'll write a parent class, and here I'll just write def uh, init. So I'm writing a constructor self, and I will just write three variables a, b, c. Okay, I'm not going into complication. Self dot a equal to a, self dot b equal to b, self dot c equal to c. Then what I'll do, I'll write a method. So I'll write def test method, and I'll pass self because it is a normal method. I'll write print this is test method from parent class. Okay, fine. So in this way we have written a one class, that is a parent class. So from our example, let's say this class, all the logic and everything was written to create a simple calculator. Now I want to create one more class, but I should make use of parent class while creating that. So I'll create that. I'll write class child. The name of the class is child, and I want to inherit it. Okay, so for that the syntax will change little bit. So I'll give parenthesis, and within parenthesis I'll write the name of the parent class, that is parent. Okay, so when I write something like this, that means this child class is inheriting its properties from parent class. Okay, so here also I can do one thing, that is I'll write init. Okay, and I'll add self, then a, then b, then c, and just like I told you, child class representing the scientific calculator. So maybe I am adding some extra features on top of the simple calculator, that is, so I'll add some extra variables here, considering some extra features are added, and some new methods also I can introduce, and existing the init method and test method will come down as it is. Okay, so here what I'll do, I'll write parent dot init, and there I'll pass self a, b, and c. Okay, and did I do it correctly? We'll check that. And after that I need to assign some value for d and e. So I'll write self dot d equal to d. I'll write self dot e equal to e. So init constructor is completely done. Then I'll call def, and again I can redefine the inherited method. Earlier there was a test method. I'm just calling it as it is, self, and I'll modify this method. So whatever existing methods are there, I can modify that in child class. So I'll write print this is test method from child class. That's it. Now there is a parent class, there is a child class. Child class is inherited from the parent class. Now I'll try to create two objects. One is p1 using parent, and I'll pass some values 1, 2, 3 for ABC. Okay, it's done. Now I'll create C1. It is a object of child class. So child, I'll pass 4, 5, 6, 7, 8, 5 values. 3 for ABC and 7 and 8 for 4, 5, 6 belong to ABC, and for D and E that will be 7 and 8. That's it. So I'll check first of all whether C1 dot A correct. So all the values are assigned correctly. C1 dot A. That means our earlier syntax was correct. I can do one thing. I can write self dot A, self dot B, self dot C, but it is not a good practice. We have already written code for ABC. So the good idea is what I'll do. I'll call the init method of parent class, and I'll pass those variables which are member of parent class. And for the remaining, I'll write the extra logic so that we reused our earlier code, right? So C1.A, correct, C1.B. Oh, there is sorry, C1. It should be C1. Correct. So instead of writing all that, I'll write print function. Print C1.A, comma, C1.B, comma, C1.C, comma, C1.D, comma, C1.E. If I do that, you can see all the values which we have passed earlier, which like belong to A, B, C, D, E, right? Similarly, if I try to do C1 dot, all the variables we have access. Now let's try one thing. C1 dot test. I'm trying to call a method. If I run this, what do you think? What will happen? It will print this line or this line, right? The print line from the parent class or child class. Let's see that. When I run this, it is showing this is a test method from child class. What does that mean? Whenever we do C1 dot test, it will since it is object of C1 is the object of child class. So first of all, it will go to the child class. Okay, there it will check whether test method is available or not. If it is available, then it will execute that itself. Okay, but if it is not available, then what will happen? I'll show you that. So for that, I'll make some changes. I'll create one more method, that is def. I'll change the names. Test1. Here, this is also test1. Then I'll write one more method, that is test2. And here what I'll do, I'll write print. This is test2 method from parent class. Okay. Here also I'll change it to test1. Here also I'll make change to test1. So basically I made some change for giving one example. Now you got the idea. In parent class, there are variables A, B, C. Then there are two methods, test1 and test2. In child class, again, I used ABCs as it is. Then I created some extra variables, D and E, instance variables. Similarly, I have created I have used make use of test1. I have modified the test1, whatever was there in the parent class. I made some changes into that. I didn't modify test2 at all for the child one, and I haven't written it, not even the same. I haven't written it at all. Okay, and that's it. So I'll run it. I'll again create object P1 for parent class. I'll create object C1 for child class. I'll print all the value once again. Same. I'll call C1.test1. So you can see it executed the test1 method from child class. From the print statement, you will get the idea. Okay. So what does that mean? Whenever you create an object, so whatever object, that object belongs to whatever class, it will go to that class. It will check whether that method is present there or not. If it is present there, then it will execute it as it is. But now what I'll do, I'll write C1.test2 and I'll try to run this. And you know that test2 is not present in child class. So whenever I try to run it, you will see what it printed. It is showing this is test2 method from parent class. What does that mean? Whenever a particular method is not present in that class for which we have created an object, then it will go to the parent class and it will check whether that method is present there or not. If it is present there, then it will run it as it is. If it is not present there at all, then it will throw an error. For an example, if I do C1.test3, and now you know test3, this type of method is not available in child class, not available in parent class. So if I try to run this, it will throw an error saying child object has no attribute test3. Okay, and even in parent class, it is not available. So if we are talking about multi-level inheritance, we'll see this in our future video. So parent class, then child class, then grandchild class. So in that scenario also, whatever object you create, it will go to that class first. If it is present, then it's okay, it will run it. If it is not present, it will go to just immediate parent class. If it is present there, it will run it. If no, then it will go to again the parent class of parent class. It will try to run it if it is present, and if it is still not present there, it will not run it as anyhow, and it will throw an error. So that was a simple single inheritance. I'll show you what we have also created P1, right? So if I do P1 dot and if I press tab, you will see only ABC. You won't see any D or E, because as I talked earlier in our real life example, generally children get their skill set, their looks, physical appearance from their parents. It doesn't happen other way around. Parent doesn't get looks from their child or some skill set from their child. Okay, the default skill set and appearances. So if I look into an object of parent class P1, I'll just see P1 dot A, P1 dot B, P1 dot C, then P1 dot test. So it will run the test function of parent class itself, because it will first search into that whatever object you have created. It will go to that class. It will check whether test1 is present or not. Here it is present. That's why it ran it. So this is a test1 method from parent class. Similarly, if I do P1 dot test2, it will show this is a test2 method from parent class. Why? Because test2 is present. That's it. One more example. I'll make some change. I'll do one thing. I'll write a test3 method in child class. So one method which is available in child but not in parent. Okay. So I'll write test3 dot self, and I'll write print this is test3 method from child class. Okay. So what I'll do, I'll just run this. I'll run this. I'm just executing all the codes. Now it ran correctly because test3 is available. So the same example I'll show you as a c1.test4, because this is not present in parent or child. It will throw an error. Then now let's begin. P1.a write, P1.b, P1.c, P1.test ran, P1.test1 ran correctly, P1.test2 it was also correct. Now I'll write P1.test3. As you know, test3 method is available in child but not in parent. So whenever we create object for child, it will check in the child class first, like the object, it will check in the class for which we have created the object. If it is not present there, it will go to parent class. It will check whether that method is available or not. But right now we have created the object of parent class, and that test3 method is available in child class but not in parent class. So I'll run it, and you can see if you create the object of parent class, it won't go. It will go first to the correct class. It will check method is present or not. It won't go to the child class to search for method. Okay. So that's why in my earlier diagram, you know, the arrow, I have created an arrow. So it was a parent, right? And I have given arrow something like this, right? So that child, I'll write here, it is a base class, it is derived. Okay. So that if I create any object that is C1 for child, so it will search for methods and variables in child first. If it is not present in child, then it will go to parent and search. Okay. But if I create an object P1, okay, then it will search for all the methods and variables in parent class. If it is present, it will execute it. If it is not present, then it will go and try to search if any other parent class is available on top of this, but it won't go in this direction. It is simply not. I'll change the color. So this direction, it will never go. Okay. To search for method or variable. So I hope you got the idea. Okay. I tried my best to make it simple for you. What is inheritance and how it works and why it is necessary. So in my future video, we'll talk about other type of inheritances. So this is all about single inheritance. If you get some knowledge from this video, please like, share, subscribe, comment, do each and everything you can do to encourage me. This is Akshay Daga signing off. Thank you. Bye bye.